Good day everyone, welcome to all. My name is Sachin Ahankari, working as Assistant Professor, Narasimha Reddy Engineering College in ECE department. So today in this lecture, we will see about the internal schematic of 741 op-amp as well as the block diagram of op-amp. So the description for the schematic as well as for the block diagram is same. So if I go towards the block diagram, if I go towards the internal schematic, it is a complicated one for the 741 in actual. So if I go here, there is a you can call it as the first stage of differential amplifier is dual input balanced output differential amplifier. So here it is the first stage and it is a dual input balanced output differential amplifier. The second stage of differential amplifier is dual input unbalanced output differential amplifier. The first stage is directly coupled to the second stage. So you are not using any resistor, capacitor or inductor here for the coupling purposes. That is the output of first stage is directly given to the input of second stage. So first stage is dual input balanced output differential amplifier. Second stage is dual input unbalanced output differential amplifier. And because of the direct coupling between these two stages, uh, the DC level at the emitter goes on increasing. So, which shifts the operating point of succeeding stages, and your output may get distorted. So, as the DC level is going to increase and which is going to distort the output voltage, we are interested to bring down the DC level down to 0 volt. So, in order to do that, we are using level translator circuit. So, level translator circuit such as emitter follower with constant current source is used as a level translator circuit to bring the DC level down to 0 volt. And the output of level translator circuit is given here to the last stage, which is complementary symmetry push pull amplifier. Uh, this stage provides the maximum gain. Uh, this stage provides the maximum voltage swing, not the gain. The gain will be provided by the first two stages. That is, a dual input balanced output differential amplifier will provide the maximum gain here, and this complementary symmetry push pull amplifier is going to provide you the large amount of voltage swing. So it is used in the output stage here. So and you are going to get the output from the push pull complementary symmetry amplifier here. So this is a schematic of your 741 IC, and if you go for the block diagram, the description is almost similar. The first stage is dual input balanced output differential amplifier. You are having the two inputs there, inverting and non-inverting input, and since it is a balanced output, the output is taken from the two collectors. That's why it is dual input balanced output differential amplifier. So two inputs and two outputs are there for the input stage, and dual input unbalanced output means only C1 and ground or C2 and ground is used, so therefore there is only one output. So the first stage is directly coupled to the next stage. The first stage is dual input balanced output differential amplifier. The second stage is dual input unbalanced output differential amplifier, and this stage is directly coupled to the next stage, and because of the direct coupling between these two stages, the DC level at the emitter goes on increasing, which shifts the operating point of succeeding stages, and which is going to distort your output also because of the a rise in the DC voltage. So in order to bring the DC level down to 0 volt, we are using emitter follower circuit with constant current source, which which is going to bring down your DC level down to 0 volt, and the output of level shifting network is given to the output stage. In the output stage, we are using push-pull complementary symmetry amplifier, complementary symmetry push-pull amplifier, which is going to provide a large amount of voltage swing, and it is also going to provide you the low output resistance. So these requirements are fulfilled by this complementary push-pull amplifier. It provides low output resistance as well as it provides the large voltage swing at the output. So here we are going to get the output from the complementary symmetry push-pull amplifier. So this is about the internal schematic of your this is the internal schematic, and this is the block diagram of 741. And in the next lecture we will go for op-amp characteristics, and after that we will classify the characteristics into AC characteristics and DC characteristics. So I am going to stop here. Thank you.